Hi everyone, it's Mr. Jensen. Today I would like to go over the density concepts that we learned in class over the past 2 days. Just for a refresher, we started density with the experiment or phenomena where I took a warm beaker of water and a cold beaker of water. I poured them together and we saw how they reacted. From our results in class, we found that the red warm water was sitting on top of the cool blue water. So here are some concepts that we want to remember from density. So the first concept that we want to remember from density is that the only thing that can change density is going to be heat. So heat changes density. All right, so how does heat change density? So for our experiment, I took a beaker, right? And we put water in it and we turned it blue to represent that it was cold. In order to get this water cold, I put it in a refrigerator, but I'll just draw in, these are ice cubes. So imagine this beaker of water, this cold beaker of water, is cold because it is surrounded by ice cubes. Then I took another beaker and we filled it with water and we put red food coloring in it to represent that it was going to be warm. How did I warm this? I put it on a heating plate. And I plugged it in to our outlet. So what happened to the densities of each that made the red water go on the top and the blue water go on the bottom? So when we are cooling or taking away heat, take heat away, we are creating a low density. So we're creating a high density. So because we made this cold, or we took heat away, we created water, the blue water, that had a high density. When I gave heat to this place, I added heat to this water, we were creating water with a low density. So in general, as you go from something cold with a high density and you add heat to it, it will lower its density. So heat changes density because if you add heat to something, the density will get lower. So because our red water had a low density, it was able to sit on top of the high density water. The second concept that you want to know for density is that unless you're using heat, density doesn't change unless you're using heat. So density doesn't change with size. So size will not change density. So in class, we did an activity, or we did a problem, where we had a bunch of samples of halite. So I'll try to represent that. So here is one big chunk of halite, right, with a density. So this halite, right, imagine I took a hammer and I smashed it, and now I have a bunch of smaller pieces of halite instead. The density didn't change at all, so this density is equal to the density of each individual little piece of halite. So there's no change in the internal arrangement of atoms. The density atoms are all equally the same distance from each other, and so the density is never changed. So if you break something into smaller pieces and smaller pieces, the density will not change because the mass and the volume are changing in that perfect ratio, that the density formula will always be the same. So then we did some practice where we actually used our density triangle. So for this example, I'll draw out our density triangle. Oop, that's not the best triangle. And you have to be able to fill out the density triangle, and there was a little tip in class today where we thought of a heart, and you thought of 2 letters from the alphabet that could create a heart. So those two letters, one was an M on top, the second was a V on the bottom. Basically, as long as you can remember that M is always on the top, you can fill out your density triangle perfectly. So M goes in the top, V doesn't matter which one it goes into, and then D goes into the last third spot. So in this question, we are asked, a loaf of bread has a mass of 500 grams and a volume of 2,500 centimeters cubed. What is the density of the bread? So this question is straightforward. It's just looking for density. So maybe I don't need my density triangle. Maybe I can just use my density formula. So D equals M over V. If I substitute my mass, I'll circle in red, and I know that this is my mass, 500. I know that because mass is taken in grams in the metric system. I can set up my formula to be 500 grams over my volume, which is 2,500. I know this because centimeters cubed measures volume in the metric system, and I can do 2,500 centimeters cubed. So when I do that, I will get 500 divided by 2,500 equals. This bread here will now have, or will always had, a density of 0.2. And now my units are going to be grams per centimeter cubed. When you're doing division with two different units, the rule that I like to remember is that it's top per bottom. So this is the top of my division, this is the bottom. So grams is on top, centimeters cubed is on the bottom, grams per centimeter cubed. And that is a straightforward D equals M over V density question. Density questions, though, can get a little bit more involved when, for example, the question asks for something like its mass at the end instead of asking for density. This is when the density triangle becomes very, very helpful. So the density of a substance is 4.0 grams per centimeter cubed. If a sample of the substance has a volume of 25 centimeters cubed, then what is its mass? So this is where the density triangle is really going to help you out. So I'm going to zoom in so I have room to draw my density triangle. And per usual, I think of a heart. I put the M on the top and the V and the D on the bottom. So I like to use the density triangle to fill out my formula. So I'm going to draw maybe a bigger one. Let's see. A bigger triangle to fill everything out. So now instead of substituting with the formula, I'm going to substitute with the triangle. So in this case, I have to zoom out a little bit, go back to my question, and I'm given a density, which is 4.0. I know this because density is taken in grams per centimeter cubed or grams per milliliter. So I'll plug that in to my density spot. I'm just going to write 4. I'm going to make my pen a little thinner. Then I'm going to take my volume, which I'm given, and I find that to be 25 centimeters cubed, because volume in the metric system is recorded as centimeters cubed or milliliters. So according to my density triangle, that's the bottom right. So I put that in the bottom right, my 25. So mass is what I'm missing on the top and what I'm looking for. If the numbers are side by side, what you do is multiply. So I will do 4 times 25, and that is going to equal 100. And since it's mass, mass is going to be taken in grams. Now, how does that stack up if I were to put in my units and think of some math concepts? So I had, 4 grams per centimeter cubed, and I multiplied by 25 centimeters cubed, and I got 100. So how did I know to put grams? Because here I have centimeters cubed, and here I have centimeters cubed, and if there's two of the same unit, one of the same unit on each side of the equation, you can cross those out. So I'm left with here just grams. And I'll bring that over here, and that's why it's specifically 100 grams. All right, so we did a question where we were looking just for density. We did a question where we were looking just for mass. And now this last question example, we are going to be looking for volume. So when you're asked for volume, it's going to be the same type of technique. What I'm going to do is draw out my density triangle. I'm going to put my mass on top because the M is the top of the heart. V is the bottom of the heart, and then you can put density in the remaining section. So then I like to, instead of doing the whole formula, I like to do a density triangle to fill out. And now I could read my question and plug in what I have. So you have a lead ball with a mass of 420 grams. So I'll circle that. I know it's grams because in the metric system, mass is calculated in grams. So here I will put 420. The density of the lead is 10.5 grams per centimeter cubed. Well, it tells us it's the density. And also I know density is taken either grams per centimeter cubed or grams per milliliter. So according to my density triangle I drew, density goes in the bottom left. So this is 10.5. And I like to do this, I like to add a question mark because that's what we're looking for. We're looking for volume. All right, so if they are stacked on top of each other, 420 is on top of 10.5, that is going to be a division problem. So this formula will end up being 420 divided by 10.5, and this is grams per centimeter cubed. This is grams. So before I even do the answer, we can get rid of both of the grams, and we are left with centimeters cubed for our unit when we find the final answer. So I take my calculator, I do 420 divided by 10.5, and my volume here would end up as 40 centimeters cubed. All right, so that is our quick review of the density concepts that we have gone over in the past 2 days. All right, if you watched, thank you for reviewing and have a good rest of your day.